Let us continue on the electron dot structures of the following molecules. We'll start with HCN. HCN is a molecule composed of hydrogen atom, carbon atom, and a nitrogen atom. The first thing is to pick the central atom. The central atom will be the atom with the lowest electronegativity except hydrogen. So we will not put hydrogen in the center. Hydrogen will never be the central atom. So we look at the carbon and nitrogen electronegativity and find the atom with the lowest electronegativity. For that, you can look in your periodic table of elements. We look at carbon, which have 2.5, and nitrogen with 3.0. So which atom have the lower or the lowest electronegativity? That's 2.5, and that's carbon. So we'll put carbon as the center. So carbon will be the central atom, then we'll have H as the terminal atom as well as the nitrogen atom. The next thing would be we'll try to look on their individual valence electron. So again, the electron dot structure shows the valence electrons of every atom. So all the valence electrons must be shown in the electron dot structure. So H have how many valence electrons? 1. Carbon have 4, and nitrogen have 5 valence electrons. Again, they bond because they want to have carbon wants 8, octet rule. Also for nitrogen, octet rule, and hydrogen, it's a smaller atom. It follows the duet rule. It wants 2 valence electrons. Right now, hydrogen have 1 valence electrons, but it wants to have 2 valence electron. It needs more 1 valence electrons. So hydrogen will reach out to carbon asking for 1 valence electron. It will form a single bond. So again, hydrogen have 1. It is asking for carbon to share one of its valence electrons. So carbon will share its 1 valence electrons to hydrogen. Therefore, hydrogen now have 2 valence electrons and is now happy. Let's look at the other terminal atom. So N have 5 valence electrons. It wants to have an octet or to have 8 valence electron. It needs more 3 valence electrons. So it reached out to carbon asking for 3 valence electrons. And so the carbon gives or shares it 3 valence electrons. Again, this is a mutualistic relationship. When nitrogen asks for 3 valence electrons, carbon also asks for 3 valence electrons from nitrogen. So we have here, it now have 3 more valence electrons from hydrogen, therefore gaining an octet. The next thing would be make sure to put all the valence electrons of individual atoms in your electron dot structure. So hydrogen must have 1, carbon have 4 valence electrons, and nitrogen have 5 valence electrons. Let's check whether these valence electrons are represented in your electron dot structure. So hydrogen have 1, which is here, which is correct. Carbon must have 4 valence electrons, 1, 2, 3, 4, which is also correct. And N must have 5, 1, 2, 3. So we need more 2 dots here to represent the 5 valence electrons of nitrogen. If we check, all atoms are actually stable. Hydrogen wants 2, so we have 1, 2, which is stable. Carbon wants 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Also stable. And nitrogen 1, 2, 3, 4, 5, 6, 7, 8. So this is the final electron dot structure for HCN. The next molecule will be SCl2. You can try this one and pause this video. The next molecule is SCl2. It's a molecule made up of sulfur atom and chlorine atoms. The first thing is to pick the central atom. The central atom will be the atom with the lowest electronegativity. So sulfur have 2.5, and Cl 3.0. So which of these atoms have the lowest or lower electronegativity? That's 2.5, which is sulfur. So the sulfur will be the central atom. Sulfur central atom. Then we have the chlorine atoms as the terminal atoms. Again, these two means there are two atoms of Cl in this molecule. The next would be to know their valence electrons. So chlorine have 7 valence electrons, sulfur have 6, and Cl have 7 valence electrons. The second step is to satisfy the terminal atom. So they need to have 8 valence electrons. So chlorine have 7, it needs 1, and Cl wants to have 8, but it have 7, so it also needs 1 more valence electron. So for this case, Cl will be asking for 1 valence electron, forming a single bond. The same thing for Cl, asking for a single bond, or asking for 1 valence electron from sulfur, also getting a single bond. Next is to make sure all the valence electrons are represented in the electron dot structure. So Cl have 7 valence electron. That's 1, 2, 3, 4, 5, 6, 7. Cl must also have 7. That's 1, 2, 3, 4, 5, 6, 7. And sulfur must have 6. We have 1, 2. We still need to put 4. 1, 2, 3, 4, 5, 6. So this is the final structure for the SCl2 molecule.